So let's talk about the marking scheme of that 2.2 and solutions to the questions in there. You would find that most of the multiple choice was based on density and pressure. So looking at question number 1, I'm not going to go into detail. I'm just going to look at some of the points that you needed to focus on. In this case, you needed to do conversions. So the 600 cubic squared centimeters and the 40 centimeters, you needed to convert to cubic meters. Because in this equation, my work done is going to be in joule, which means my pressure is going to be in pascals and my volume is going to be in cubic meters. So that was the trick in there. Okay, question number 2. So just a brief overview of the test in that sense. I'll post the memo in itself as well, and you can go through it and ask questions should you want to. A hailstone that is initially at rest, the base of a cloud falls vertically towards the earth. The diagram shows the magnitudes and directions of the forces acting on the hailstone as it starts to drop. Alright, so the first thing is my gravitational force, my weight, needs to stay the same, and yes, in all my answers my weight stays the same. That's fine, so we're not even going to focus on it. Then my upthrust. What is upthrust? Upthrust is the force due to the pressure difference. What pressure difference? Between the top and the bottom. Now my hailstone remains the same size, so that upthrust between the top and the bottom is going to stay the same. That's not going to change. The only thing that's going to change is this. Is my viscous force. Well, if it's falling through a liquid, the viscous force, or it's sometimes referred to as the drag force, and you may also know it as a frictional force. And the frictional force is the one that's going to increase. Up until a point, they say terminal velocity, we know all my forces down must equal to my forces up. So those two must be equal. So if I add my viscous force and my upthrust, it must equal my weight. So yes, I know it's a sketch type of drawing. It's not going to be measured. But we said our upthrust must stay constant. So actually, no. D is your only option that you do have in there. Okay. Number 3, basic application of formula. Again, just needed to convert your height, literally, or your depth in there to cubic meters, get to a Pascal, and then it was rounded to 3 significant figures in there. What do we have next? Next we have, so interesting, they say this is the volume of a gold atom, and it may be considered to be a cube. So you needed to see, okay, what is the volume of a cube? It's literally all the sides are equal, so I did it in green and purple and red to see. And again, conversion from centimeters to meters. I did that. It's actually not necessary to do that now that I see that, because my density was actually in that in grams. So no, you didn't need to convert to meters. I'm sorry. It's because I didn't do the calculation. Silly me. We could keep that. Actually, it's good that I notice it now. You keep it in centimeters. We would do that like that. And so if it was in kilograms per cubic meter, I needed to do the times 2 to the negative 2 in there. Okay, so it's actually grams. Oh, your teacher should be awake when he does something like this. Right, and then obviously formula that we applied.
Want to dig with me?
The fun.
The hand up and come back to it. Oh, Dad. No. Okay.
Right, so quick interruption by the toddler that is explaining literally he's going to water the garden as it's east weather outside. Okay, so I've marked a few of the tests now. Define pressure. We define it by using our formula. So force per unit area, literally, and this is what you will write in words. Don't do something else. Write it out in words. If you just state the formula, you will not get the mark. You have to do it in words, please. Okay, number B, 5B was a very nice question. This was a question that you had to think a bit on. And yes, you can say unfair and scream and shout at me. It's fine, you can do that. I'm not going to hear it in any case. You needed to think about the following. What is pressure? Pressure is force over area. But where does that force come from? That force comes from the rate of change of momentum. Because what happens? My molecules collide with each other, and each time they collide, there's a force present. Think about molecules. If you just think about it in a container, for instance. There's my container and my molecules. They're going to collide, and they're going to rebound. And in there, that is a force being applied on a certain area. That gives me pressure that is caused by these molecules. All right? Now, a lot of you had this next point. You said, but there's fewer air molecules higher. Okay, but you need to quantify it. There's fewer air molecules per volume. Ivan, I think I gave you the mark because you said it's less dense. And yes, you needed to read into it a bit. I don't think the final examiner will give you the mark either, though. You can't just say fewer molecules. It's fewer molecules per volume. Or specific volume. Also, they will have a lower speed because there's a lower temperature in there. So, coming back to my rate of change or change in momentum equation, this one that I'm underlining and also highlighted, if my speed, my change of velocity is less, I will have a smaller change in momentum. If there's a smaller change in momentum, I will have a smaller force. If there's a smaller force, I will have less pressure. So this was what the question was based upon. Nice question. Keep it in mind. And this is how they integrate questions. Right, let's move on to the next question. Nothing too weird. You needed to think about, okay, we've got this container, there's a specific cross-sectional area, there's a specific height, and they give density. Look now again at the units. Are they in the correct unit? Yes. That means my mass is going to be in kilogram. They're not looking for mass, they're looking for weight. You needed to convert by multiplying by 9.81. Remember, that weight is nothing else than a force, and again, force, mass times gravitational acceleration that you're going to use, and we always in physics AS use 9.81. Okay, again, rounded to two significant figures. I didn't penalize anyone for doing more significant figures in there. Calculating a pressure, force divided by area, we did it. We got it. All right. So why is there a difference in pressure? Well, because air pressure acting on the surface of the liquid. So it's not only the pressure of my liquid, it is plus the atmospheric pressure in there. That gives me the total pressure. Total pressure at the bottom. Okay, so yeah, again, remember the last question in each or the last subsection, let's call it section in each question, is your higher order thinking question. It's going to be the tough one, the one that you need to think a bit further, that the one that separates your A's from your B's or your A pluses from your A's. That's that question. Okay, Number 6, we've got the cylindrical disc. Define density, it's mass per unit volume. Again, mass per unit volume. Theodore, I subtracted 1 mark because you said mass in unit. I don't know where you got in, but you did it consistently throughout. I just subtracted 1 mark. I believe the examiners will also do that because they would see it is a language mistake and it's not hopefully a concept mistake. We hope so. But please correct your theory in that one. Then the disc has that diameter and the thickness of that. Again, similar type of question. To 2 significant figures, please calculate the weight of the disc. So we go through the whole thing again. There's my volume, which is area pi radius squared times height, times the density of it gives me a value of mass in kilograms. I'm not worried about the number of significant figures within the question. It's in my final answer. This one, 0.49, 2 significant figures. So here they're testing that question. This is the skill. If you didn't get 2 significant figures here, you would not score the 4 marks. Okay? So, and again, please write your formulas. You're getting marks for the formulas in here as well. So if you just wrote the answer or did some scribblings and then got to this, you might only get 2 out of 4 in a final exam. So be careful. Definitions. I did ask quite a few definitions. Acceleration, rate of change of velocity, or a change of velocity per unit time. Newton's first law, a body continues at constant velocity unless a resultant force is acted on it. Okay, so it must be a resultant force, not just a force. Okay, so components, I think you guys, you are sorted with your trigonometry. Think about costs, think about sine. Not going to go into that. Okay, then we get to the C question where you had to draw a vector diagram. There's my vector diagram. I know it looks small, but there we go. Guys, always start with a perpendicular or a horizontal component in there.
Dad, the dog was making me a cup of tea.
Okay.
Okay, go on.
So, guys, you know, I've used this method for a long time. Please use my method. You know, I can't force you to use my method, but please do. You know, if you've got other methods that work, but I've seen some weird stuff going on in there, you need to have the directions correct, the orientation correct in there. You need to have the angles and the labels correct in there. So T1 can't go a different direction than up at otherwise than 50 degrees to the horizontal. Even if you did the parallelogram method, you would have something like that, T1 and your purple one, T2. So even if you did that method, your T1 and your T2 will still be in the correct direction or correct orientation and weight being down. All right. So doing that, you see you get a 90-degree triangle. You can do the calculation, show the calculation, and you score your marks in there.
I'm taking a jump rope to watch, see how the dog can jump.
So,
Teach me to jump.
if you think, you saw Philip Joseph. Here we go. So, definitions. Please, please, please make sure that you have the correct definition. Please make sure that you have it written down correctly. Center of gravity, point where the whole weight of a body may be considered to act. So red 1 mark, blue 1 mark. Define the moment of the force. It is the product of a force and perpendicular distance to the pivot. 2 marks. two conditions necessary for equilibrium. No resultant force, no resultant moment. Principle of moments. Sum of the clockwise moments must equal the sum of the anti-clockwise moment around a point, right? So this isn't about the closed system like with momentum. This is moments. Define the force couple. So the red is actually not the definition per se, the two equal but opposite forces acting or causing a turning effect. The correct definition is the one in blue. One force multiplied by the perpendicular distance between the forces. Right? If you think about the formula, it's actually a tau. You can just write force couple if you really want to. And then it's force times perpendicular distance again. But that perpendicular distance, actually, like this perpendicular distance, is the distance between the two forces. Think about that force going up and that force going down, and that being your perpendicular distance in there, and that's one of the forces. So think about that. They must be in opposite directions, so a lot of the times I've given one mark for that. If you say two equal forces but in opposite directions, then I've given the mark. So that's where that comes in. Okay, an interesting question with this, where we have this disk and this force F being applied to it. So there's force F that's being applied. This is going to cause this anti-clockwise moment in my disk. But now they say, listen, there's two other strings, S1 and S2. This is S2, and this is S1 being applied to it so that there's no turning moment. Just one.
Okay. And the camera is wood. Can you
Yeah. So, in order for this not to turn anti-clockwise, I must apply a force on S2 to that direction, so away from the disk, and S1 also away from the disk. So S1 you could have said then to the left and to the right. This is the way that I stated it in my marking scheme. The original question said to draw it on the sketch, but because you had the option to do it on an A4 page, I said, write it. Some of you showed it as well. That's fine. If it's in the right direction, I've given the mark in there. You can't tell me, well, it could be one way or the other. No, you have to figure that one out. Okay. And now, obviously, we can calculate the moment due to that force F. And then the torque of the couple must be the same. It's just going to be in the opposite direction. Okay, so it's still 45 Newton. Applying that formula of torque of one of the forces times the perpendicular distance between the forces, now we can get the magnitude of that force in there. So this in essence was, well, this 2 marks, 1 mark, 1 mark. That's where we got the 4 marks from. Okay, last question. We're dealing with a uniform beam. What does that mean? This means that the distance is exactly 0.2 meters for that W in there. We have this beam or bar that applies a force at an angle, and now we need to calculate its vertical and vertical component. Why? Because that vertical component, look at what it is. It's actually this force that's going to work in there. And remember, what's my definition? It's perpendicular. We're working perpendicular, so we can't work with a force at an angle. We can only work with perpendicular. So that blue one, if the horizontal component of that bar is not going to contribute to the moment. It's only the red force that will contribute to the moment. So we have two forces working clockwise. That is going to be my 12 Newton this way, and my weight, that's going to take it clockwise, sorry, like that, and then my red one taking it anti-clockwise. So when I do my calculation, it's going to be by clockwise moment equal to the anti-clockwise moment, but the sum of, or total, that's how we write it. Then we do our substitution. Yes, you could have added a line in there, force perpendicular distance, force times perpendicular distance, force times perpendicular distance in there. That's fine, plus. And now we calculate it, right? So you can't use the angled one or a force, and it must be the perpendicular distance from my force working in there. Okay, so guys, go through this. If there's any questions, do ask. Otherwise, good luck for the exam. I hope you're going through the revision videos. I hope you're working through the old worksheets. Ask if there's anything, and yeah, good luck.